Good morning and welcome to math class. Today we are covering lesson 7-6 and we're going to be looking at the hierarchy of quadrilaterals. So yesterday we looked at the hierarchy of triangles and today we're going to be looking at quadrilaterals. So for our math message, I have included in your module the Math Masters page, and it has quadrilateral cards on it this time. If you can print those out and cut them out, that would be great. If you don't have access to a printer, that's okay. You can just draw them on little pieces of paper if you'd like, just so that you get the idea of what it is that we're talking about and what we're doing. So I want you to take those quadrilateral cards and I want you to complete the top of the first page in your math journal pages, where at the top of the page it says a quadrilateral hierarchy, and then it even says math message. So I want you to match up some of those quadrilaterals with those descriptions that are in the top half of the page. Once you've completed that, then go ahead and restart the video. All right, now that you've had time to do that, let's work through it together and see what you decided. So the first one says a trapezoid is a quadrilateral that has at least one pair of parallel sides. Now remember, if something is parallel, that means they're always the same distance apart. So it's two lines that are never going to run into each other. So for a trapezoid, you could have put, and remember there could be several answers for this, I'm just giving you examples. You could have put quadrilateral D for that one, because letter D is definitely a trapezoid. It has at least one pair of parallel sides. The next one says a kite is a quadrilateral with two separate pairs of adjacent equal length sides. Now remember, adjacent means next to each other. So it has to have two separate pairs of adjacent equal length sides. So letter K is an example of a kite. So we're going to put letter K there. The next one says a parallelogram is a trapezoid with two pairs of parallel sides. So if it's a parallelogram and it's a trapezoid, so it has to meet both of those definitions. So letter G would be one that fits that, because it has to be a trapezoid, which means it has at least one pair of parallel sides, but a parallelogram has two pairs of parallel sides. The next one says a rhombus is a parallelogram with all four sides in equal length. So an example of that would be letter A. Has to meet the criteria for being a parallelogram and for being a rhombus. A rectangle is a parallelogram with four right angles. So a good example of that would be letter C. So it's a parallelogram, which means it has two pairs of parallel sides, but to be a rectangle, it also has to have four right angles. And then finally, the last one is a square is a rectangle with all four sides equal in length. So a good example of that one is letter L. Okay, let's talk about a few more examples that we can see with our quadrilateral shapes. So look at quadrilateral P. Is quadrilateral P a trapezoid? Some of you may think it's not a trapezoid because it has two pairs of parallel sides. But the definition on our journal page says that a trapezoid is a quadrilateral with at least one pair of parallel sides. So this means that a trapezoid could have either one or two pairs of parallel sides. Therefore, quadrilateral P is also a trapezoid. Now let's look at quadrilateral A. Is quadrilateral L a kite? Two separate pairs of equal length sides in a kite can be two identical pairs. So all four sides of a kite can be equal in length. So quadrilateral L is also a kite. Remember the activity from yesterday in which we classified triangles in a hierarchy. So here's an example of our triangle hierarchy. Remember that all the triangles fit into the top category because they are all regular triangles that share certain attributes. They all had three sides and they all had three angles. Some, but not all of the triangles were moved to the isosceles triangle subcategory because they had an additional attribute. They had at least two sides that were equal in length. Then some, but not all, of the isosceles triangles moved to the equilateral triangle subcategory because they had another attribute. All three sides were equal in length. This is a basic principle of hierarchies. The most general category is at the top. Some, but not all, items in the general category can be moved lower into more specific subcategories if they have certain attributes or properties. Why might it be helpful to classify shapes in a hierarchy instead of just looking up definitions of shapes? Hierarchies show how shapes are related to each other. They help us keep track of the general and specific properties of shapes. Today, we're going to explore how to classify quadrilaterals into a hierarchy. Look at your next page that's found in your math journal pages. This page shows a hierarchy that mathematicians sometimes use to think about quadrilaterals. Now, I couldn't fit the entire page into our picture, so right now I just have the top part of the page. What do you notice about this hierarchy? How does it compare to the hierarchies we looked at in the previous lesson? Well, this hierarchy is much more complicated. It shows more categories. Sometimes there are two arrows coming from a category instead of just one. Like you see here where the quadrilaterals are, there's two arrows to the trapezoids and the kites. This hierarchy is called a branched hierarchy. When a category has more than one subcategory, mathematicians use branches to show the subcategories. For example, the hierarchy shows two subcategories for quadrilaterals, trapezoids and kites. Name another category on the quadrilateral hierarchy that has two subcategories. The parallelogram category has two subcategories, rectangles and rhombuses. You used properties to check whether triangles could move down the triangle hierarchy yesterday. You can also use properties to check whether a quadrilateral can move down the branches of a branched hierarchy. You can think of these properties as tests that shapes have to pass to move down. Refer back to your definitions on the first page if you need to help you as we move through this process. Now look at your cards. Are all of the figures quadrilaterals? Yes. How can you tell? They all have four sides and they all have four angles. What is a property that you can use to test whether a figure is a quadrilateral? It has to have four sides and four angles. So we're going to write four sides and four angles on this line next to where it says test property. Four sides and four angles. I kind of run out of room with this pen. Okay. Are all of the quadrilaterals on your cards trapezoids? No. Some, but not all, of the quadrilaterals are trapezoids. So if we looked at quadrilateral A, is this quadrilateral a trapezoid? Yes, it is. How do you know? It has at least one pair of parallel sides. So what property can you use to test whether a quadrilateral is a trapezoid? It has to have at least one pair of parallel sides. So write that on our test property line for trapezoids. So we're going to write at least one pair of parallel sides. Now, we're going to do the same process for kites. Are all of the quadrilaterals on your cards kites? No. Some, but not all quadrilaterals are kites. So look up the look up the A quadrilateral again. Is this quadrilateral a kite? Yes. How do you know? It has two pairs of adjacent sides that are the same length. So what property can you use to test whether a quadrilateral is a kite? It has to have two pairs of equal length adjacent sides. So what should we write on the test property line for kites? Two pairs of equal length adjacent sides. So they're next to each other and they're of equal length. You just discovered that quadrilateral A is both a trapezoid and a kite. It can move down either branch on the quadrilateral hierarchy. The branches in a hierarchy do not necessarily mean that a quadrilateral has to go one way and not the other. Some quadrilaterals will not be able to go down either branch. Some will only be able to go down one branch, and some will be able to go down both branches. You will be able to see how the hierarchy works for all of the quadrilaterals in the next activity, but first you need to finish filling in the test properties. As we continue moving down our quadrilateral hierarchy, straight down from trapezoids, let me write this up here. This would have been our trapezoids from the last screen. Trapezoids were up here. So that arrow came straight down to parallelograms. Now, what are the test property of parallelograms? Parallelograms have to have two pairs of parallel sides. Two pairs parallel sides. So an example of that would have been quadrilateral G. Okay? Now, so for the bottom part of our hierarchy, we can see that both rectangles and rhombuses join together again into squares. So the property for squares is it must have 4 right angles and it needs to have 4 equal side lengths. But it's interesting that up above they branch off like here into different directions, but here at the bottom actually the rhombuses and the rectangles join together again to form squares. So let's put this all together and think about going through our hierarchy. And if we started with a quadrilateral and worked our way through this process, we would need to start at the top and test the quadrilateral using the test properties at each intersection. You then would leave each card next to the lowest category into which it will fit. Remember that if you reach a test that a quadrilateral does not pass, you need to check to see if there's a different branch the quadrilateral could follow. For example, if a quadrilateral does not pass the test for a trapezoid, you should try testing it as a kite. As an example, let's go through classifying quadrilateral A using the following steps and questions. So if we started at the top with our quadrilaterals category, the test property is 4 sides and 4 angles. Does shape A have 4 sides and 4 angles? Yes, so it is a quadrilateral. Now, can we move quadrilateral A down to the trapezoids category? Think, does this shape have at least one pair of parallel sides? Yes, so it is a trapezoid. Now try to move down to the parallelograms category. Does this shape have two pairs of parallel sides? Yes, so it is a parallelogram. Now try to move down to the rectangle category. Does this shape have four right angles? No, so it is not a rectangle. Now go back up to the parallelograms category for now. There is another branch to check. Try to move down to the rhombus category. Does this shape have four sides that are the same length? Yes, so it is a rhombus. Try to move down to the squares category. I know it has four sides the same length. Does it also have four right angles? No, so it is not a square. Leave it next to the rhombus category. Now, I would like for you to work through classifying the rest of your cards and try to get them to the lowest category into which a card can be classified. Once you have finished that, then I want you to remember that quadrilaterals in a subcategory have all the properties of the quadrilaterals that are in the categories above them. That's how we work through a hierarchy. So now that we've finished that, I would like for you to complete Math Boxes 7-6 and HomeLink 7-6, and then that will be all of your work for today. You will be off for the next several days for the weekend, so enjoy your weekend. And once again, if you have any questions, be sure to send me a message through Canvas. Please make sure when you are submitting your assignments that you are submitting them to the right place where they belong. They should be labeled, Math Boxes 7-6 or HomeLink 7-6 when you submit them. Have a great day.